Okay, what we're going to do now is we're going to look at how to multiply and add square roots. Okay, now this is pretty nice actually. For multiplying square roots, what we're going to do is we are going to try and come up with a rule here. Okay, so if we have the square root of 4 times the square root of 9. All right, let's have a look at that. Now, we know that the square root of 4 is 2. Okay, and the square root of 9 is 3, okay, and that is 6. Now, I want to try something different here. Instead of doing it this way, what we're going to do is we're going to write it as the square root of 4 times 9. Okay, so we're going to try it this way instead. So let's look at it as the square root of 4 times 9. What's 4 times 9? It's 36. And so now we have the square root of 36. And what is the square root of 36? That is 6. Now you can see that this lovely 6 here is the same as the 6 we came up with here. Does this work for other numbers? Let's try it. Okay, the square root of 25 times the square root of 16. If we do this with numbers, the square root of 25 is 5, sorry. The square root of 16 is 4. All right, 5 times 4 is 20. Let's have a look at this the long way. If we take the square root of 25 times 16, that's a little bit harder. We can use a calculator for that. Some of you can probably easily do this in your head, but let's pretend that we can't. 25 times 16 is 400. So we have the square root of 400. If we take that on our calculator, because some of you don't know how to do that one, square root of 400 is equal to 20. And coincidentally, that's the same as the answer that we got the other way. So we had 20 here, we had a 20 here. Okay, what that means is we have a nice rule here. If we have the square root of A times the square root of B, what we have is the square root of A times B. All right, and this works nicely. Now, sometimes you're going to get examples where there's also a coefficient, okay? So we'll do firstly an example without one. For example, the square root of 3 times the square root of 2, okay? Now that is the same as the square root of 3 times 2, and 3 times 2 is 6, so we get the square root of 6. Lovely, okay? You can check it on your calculator if you want, but basically, this is how it works. Let's try it with a coefficient. So instead, we're going to do 2 times the square root of 3 times 5 times the square root of 7. Okay, now this is where it's slightly different, but not really. What we have to remember is if there's a coefficient, so the number before the root, then we have to multiply that as well. So we're doing 2 times 5. Okay, times the square root of whatever's under the square roots, which in this case is 3 and 7. So we're going to multiply that by the square root of 3 times 7. 2 times 5 is 10, times the square root of 3 times 7, which is 21. Okay, and this is our answer. So this is how it works with multiplying. That's really nice, fairly straightforward. Basically, just multiply everything. Now, with adding and subtracting, it's a little bit different. The really nice thing though is with adding and subtracting, we can actually treat this like algebra. So with adding and subtracting, treat the roots like algebraic terms. Okay, now that may make absolutely no sense to you right now, but let's have a look at it. In algebra, if I said to you, what is 3a plus 5a? Okay, you guys know that that's the same as 8a. Nice and easy. Those are like terms. They've got the same variable. So there's variable here. They're both a's, so we can add them together. We get 8a. Lovely. Now, this works exactly the same with square roots. If I gave you 3 root 2 plus 5 root 2, okay, we can pretend that this root 2 is like our a, because we can't do anything with it, can we? It has to stay as a root 2. We're not going to simplify it because it's got a big long decimal, and we don't like those. We like things to be as tidy as possible. So what we have here is 3 lots of root 2 plus 5 lots of root 2, which is 8 lots of root 2. Okay, so it's almost exactly the same as with algebra. All right, now the same as with algebra, in algebra we have like terms. Okay, in roots we have the same thing, so we have like square roots. Okay, so instead of like terms we have like square roots. If you prefer to call them like terms, that's fine. Okay, it's probably a little bit easier. So for example, if we have 3 root 2 plus 5 root 3, okay, here we have our root 2 again, very nice. Okay, but over here we have a root 3. Now this is quite similar to doing 3x plus 5y. You guys know that these are not like terms, and that means we can't go any further with it. Okay, in that same way, these are not like roots. Okay, so we can't do anything else with them. We're going to leave it like that. Now the textbook says to write cannot be simplified. I prefer that you write not like roots, or that you just write the same thing over again. Okay, so if we had, for example, something like 5 root 2 plus 3 root 3 plus 6 root 2 minus 2 root 3. Okay, firstly you need to look for your like terms. So we have root 2 and root 2. Okay, so 5 root 2 plus 6 root 2. Okay, which gives us 11 root 2. Okay, and then we have, using a different color, root 3 root 3 minus 2 root 3. So 3 minus 2 is 1. We don't write the 1. It's exactly the same as algebra. If your coefficient is 1, we don't bother writing it. So it's just going to be plus root 3. All right, so as I said, treat these pretty much the same as what you would do for algebra, and it keeps everything pretty straightforward. Okay.